Hello R2CON, this is unixfreaxjp. Would like to make a presentation about the debugging and bug fixing Rudder 2 in the R2CON 2021 conference. And this presentation is about how we can support our Rudder community and development by doing a systematic process testing and bug fixing. And in this presentation, I'd like to share my experience in doing such activities, and this is the wrap up in the form of the presentation. Usually when I start any presentation, I wrote about this disclaimer that this is also about the share back knowledge to the fellow blue teams, especially in the Radar community, dealing with the bugs and how to handle them properly, and also helping with the test. Stock is not operational with no attributions and written as a educational basis. Contains the basic know-how of the Rudder tools for the related topics, and the material is based on the Rudder 2 organization research that we are doing, and there is no data nor information from the other speaker or from other groups or entities included in the any of the slides. So the contents like this, first we go with the introductions and then the explanations concept, but why the testing is actually needed, and we will doing some practical tests. It has a demonstration over there, and then we go to the bug hunting methods and how to make the good report by the Rudder platforms when you are facing the new bugs. Well, in the next slide, we will start about the introductions. First, this presentation, you are introduced to understand about the development cycle of the Rudder team and how the testing and bug fix playing a big roles in it. And it will be explained also about how to handle the situation with the bugs. And the handling is the key, that correct steps for handling such bugs or testing. You can help Rudder to developer teams to fix the bug quickly by following the suggested ways, and helping in testing Rudder to products. You're contributing much for the stability and maturity of the Rudder 2, and this is merely from my experience in doing such activities. So this is about myself, as usual. So recently I'm doing the pretty much of the testing in the Rudder platforms to help the development teams to make more stable and systematic updating and versioning and so on. You can read about this explanation later on, and moving to the next slides, pretty much talks about the Rudder environments in the previous presentation that I have in several conferences. These are the list for them, so if you want to see later on, this is a reference for you. So we go to the why the testing is needed, and then why testing is needed and how. Testing is an important step for the stable release versions in the Rudder 2 development. Rudder 2 development is defined by the set of the milestones, and each milestone explaining new base of features to be implemented in the next release, and those base to be added with more and more features as long as the development for that base is continued, while in the development the new gems and the new planning for the next milestone is actually planned and to be formed to the next milestones to go. So for index example, the latest Rudder 2 versions 5.4.2, it has the major versions. 5 means that the new base milestone is version 5. It has a new base for the new features that having planned to be implemented in these versions, and it has been developed by the additional features 4 times, hence the minor version is a version 4, and has been maintained for the bug fix like 2 times since the minor version release. So this version means that it has the version major 5 and minor 4, and we had 2 times overall testing for the products for these minor versions. So that is exactly where the testing are doing the job. In this slide, we will talk about the requirement for the testing itself. So requirement first is we need a target for testing. As we also know that Rudder 2 is supported the huge architecture of the CPUs and can be supported to the many of the operating systems. So we have to be careful in picking which kind of the target for the testing that can support the development and can actually pinching several bugs. And who will do the test in this case? First is we can, trust Mr. Travis here, which is a CI, is a program, and human, which anyone with a skill set that's capable to do so. And next, the time is needed. For the humans, especially because of the CI, it's not taking so much time for the making results, not as much as what the human does. So I will explain in details about how the human resource doing the time for the testing in this breakdown. So for the generic platforms like the servers and the commonly used desktops, overall doing the test for the new release is taking about the 1 day, like a non-stop testing for the whole days, and then you can drop to sleep later on in the next days. And it is supporting with Intel base or AMD bases. We can support with Windows, OS X, and Linux platform for that CPUs, and also we are supporting to the ARM MIPS for the Linux and BSD platforms. And for the mobile generics, the things is quite a bit different. Like one mobile platform for the testing will take like a whole day to do so, because of the speed is not as fast as generic platforms of the servers or desktops. And for the iOS, you can ask directly to the Pancake of how he does the test for the iOS. And the extended platform test is including the embedded platform here. Embedded platform CPU is very, very slow. So mostly I'm doing that with the bare-bone devices. And maybe 1 CPU per day is the maximum speed that I can take time for doing so. And lastly, where there is a bug fix that needed to be done in the any kind of the support that described above, especially where you are dealing with a blind bug fix support, it will take like 1 week in average per bug to really pin those bugs down. So let's break down first with who does the test. And for the CI, you can see the report is going like this. It's quite details, and in this screenshot you can see the report of the CI result, which is using the integration with the GitHub, and it is having the Mason base for the building the packages, and these are the result for the one test scheme. And in the testing with CI, there is a merit and there is also demerits for them. And for the merit, is a really faster check, and it is integrated to the development environment, for example the GitHub or any kind of the Gits or others, and it has the automation testing in the every or after merge of the new code, and useful for the developer to instantly check or adjusting their works with a trial and error, so that fast. And then you can almost doing the checks for the either the build is gonna be successful or not almost in the real time. And the demerit for that is first, it's supporting only a limited specific build environment configuration of the platform only. So if you are having like one OS with having multiple ways to set up the build environments, probably you have to set that one OS with multiple ways also, and that means that you have to prepare multiple CI environment for doing so. And due to the supported and unsupported kind of the build method missing, CI are missing mostly the build bugs. There is also another factors that developers tends to not maintaining their CI distribution much, and since they have to prepare so many CI and there are probably too limited devices to support those CI environments, and probably some developers knows about the coding in the environments and doesn't know what another OS is doing. So in that case, mistakes can easily occur and bugs happen. So now let's compare with the human. Human is, for example, this can write POCs, can explain about how the bug is actually happen, and then can propose about the fix in some kind of the proposals and etc. etc. So let's break down about what the human can do with the merit and demerit like this. The merit is a human can make a thorough check than a CI does, and a person with many skill set probably can support many kind of the platform to check. So the only problem is resources and time for him to do that. The second is human resources can build a team to check with bigger test platform resources, the bigger scope of tests that can be performed. So it can be delegated test works and supporting to the many platforms to be maintained at almost the same times if the resource is big enough. So CI can do the same stuff too, but I don't think that they can doing parallel like 4 operating system in the same times. And human can cover testing for build, bug fixes, and troubleshooting too, and we will explain later on in the next slides. And the next one is a human capable to do quality control or the quality assurance of the stable versions after doing the thorough checks and thorough testings, and then having no bugs or no regressions that being spotted. The demerit for that is it needs so much dedications, resource, skill set is needed too, and time. Time is as per explained in the previous slide. And testing by the human resources cannot be done instantly and needs a regularly planned in order to make a delegations and the coordination. So needed to be planned exactly strategically about the how, when, and where to make testing for the following the development process. So in this slide, I will try to explain to you about one of the strategy that I am doing in the order to performing test process of following the R2 major version 5 so far. So I made a kind of the alert systems like 1, 2, and 3 with this kind of the color. And the yellow one means that that is a kind of the progress of the development running, and then the second one is there are some additional features that can actually raise more bugs in another factors of the either the platforms or the architectures and so on. And then the alert 3 is the place where I have to do the overall test of the products again. And this is actually implemented in the version 5, and you can see the details based on this release versions of the Radar from the version 5. It has the recent one is a 5.4.2, and we are starting this session from the version 5.0.0. And the roadmap for the stability and the portability in the Radar 2 version until the 5.4.0 it goes like this in the testing circumstances. So the version release 5 is happening, and then I tag this as this color with alert 1. Let the development do the stuff for the improving and making plans for the additional features. And then when the release version of the 5.1 exists, the feature additional stuff was added to the project, and I also raised the alert too, since there are plenty of the features that can affect other kind of the platforms users too. And when the 5.2.0 release, and there is no testing was going on until that point, so I was performing the test for these versions, and it came up with a 5.2.1 which was actually stable, and it has a bug fix related result from the several tests that Pancake is doing many works too for the testing, and the full result is becoming the stable version of the 5.2.1. And again, new additional feature was developed and released, and I raised again the alert to be in this time is straight to the alert 2, because of there are some sensitive platform that actually being touched that time was making a bug for the other platform. Then we made another testing for that, and the result is the version of the 5.3.1, which is quite stable, and it has no bug anymore, and all clear at the time. And then another feature also being added again, and as previously the other platform, which is in this case is a Windows environment, was adding some kind of the changes there, and then so we think it is needed to perform another thorough test to every kind of the generic platforms, and we launched the test, and to find that 5.4.1 is goes quite stable at that time, but the one platforms cannot be pinned as quick as other platforms, so we leave it to the Git for that under decision of the Pancake, and the development for fixing the one leftover platform is continue, and the 5.4 was performed after the full test result, and the last bug fix for the leftover platform has been fixed. So this is a story actually about how the testing are continuously happening, and then when the actual test that can be performed. The strategy looks work in this rather to major version 5, so I think it will be good for the reference for the future too. So the next slide is about the operating system used in the test. So the supported operating system for the generic platforms are we are using OS X, Linux, BSD basis, Windows, Android, and iOS. In this case, you have to ask Pancake for that. And which is the supported OS versions are long-term supported operating systems, and we don't test unsupported operating systems anymore. And then the specific device or distributions that is having a specific operating systems can be supported too separately with a dedicated maintainer if the maintainer exists. And for example, like Game Boy React OS, Sergey Linux, Linux Hobbyist with exotic CPUs like Arduino and so on. CPU architecture is supported in the huge list in the router 2, so you cannot do them all, and then you have to really pick very careful selections for this architecture. So in this case, I'm focusing for the most commonly used, like Intel, AMD, ARM, MIPS, PPC, and Windows, and most of them are supporting in the 32 and the 64. bits of platform of the CPUs. We are also doing the extension test for the ARM M1 supporting to the new OS 6, and then we are having many kind of the experiment with the ARM, and currently we are, well, actually I have some boxes of the Cortex and Kirkwood running with several operating system installed, so it is done in that environments too. And then also, well, me and Pancake is having Solaris, so we are doing that separately. In this case, it's doing some custom versions. So the next is what is the strategy to approach the Rudder 2 regular test in this case? So first we are separating the test into a production test, which is aiming for the new feature to checks, and we are having the bug fixing test, which is pinning down the bug, and can be in one platforms or overall platforms that are supporting and can be installed with the Rudder with the common installation methods. And we are doing in the recent version 5, we are doing the stability and portability test, which is actually started from the 4.5. And it is really pointing to the compatibility on the OS architecture and the devices. And for the devices, it will be case-by-case matters. And this is actually quite new. It's still under experiment or development, which is the backup and restore for features of the testing environments that we are having. And probably it will be a very good ways to be implemented as a plugin or as one of the main features in the Rudder 2. We'll see about that. Now, dealing with the R2 plugins, there are two kind of the plugins here, which is one is actually plugins integrated with the Rudder source code and actually compile together with a Rudder package, with for example like compressions, plugins, and so on. And those are also another plugin which is managed by the R2PM or Rudder 2 PM. PM is a kind of the plugin management, and we are talking about the ones that are being maintained by the R2PM. So you have to understand about what R2PM is and how R2PM can install a plugin, and then where all the stuff after the plugin is installed, and then what source code of that plugin and which commit of that plugin that is currently being used by you. And then you really have to know also about how to back up your plugins, and for more information about how plugin is integrated to the Rudder core components, you have to seek those informations too before you are understanding about how to pin the bug. So in that case, you will need the information about the plugin, which is written in the R2 book, and that can be accessed online, or you can see the reference in this slide later on. Okay, we are here in the practical test, and it has two items. First is explaining about how to know the limitations of the Rudder 2 and its environment, so we can actually differ which one is bug and which one is not for the tester. And then the other one is testing in action, so we will pick one case study for the testing. In this case, probably I will pick about the build test for the FreeBSD. And let's go to the practical test, which is explaining about the first knowing the limitation for Rudder functionalities or environments. Several elimination in analysis can be misunderstood as a bug if you don't understand it. So you have to be careful with the stuff like in the debugging, for example, several systems just doesn't support the software breakpoints, instead using the hardware breakpoints, especially where you are dealing with much of the embedded or IoT devices, and some CPU probably have limit for the usage of the hardware breakpoints. For example, in the Intel platforms, it has 4 breakpoints for the hardware that can be used, and that is a very important details that you have to understand beforehand. Another thing is you can ruin a process opcodes if you are dwelling with the hex of the opcodes itself with a command like wx something, and then when you are executing that command, you don't use the IO cache protections like this. So when you are writing something with WX, you have to be sure it is be written, especially when you are in the middle of the debugging something. And it has also with the emulation like ASIL. So for example, you cannot force ASIL to go backwards without setting the initiation of the starting point for the VM of the ASIL to start. So that is one tips that one stuff that you need to understand. And not only about the analysis, but in the plugins also there are several limitations that you have to understand too. For example, in the R2DEC plugin, you cannot run PDD on non-Intel platforms like MIPS, for example, or PPCs, because of it's just not supported for that platforms. And for the R2 you just have to install R2 Ghidra integration with the Radar PM, or else well, you can compile the Ghidra, probably you cannot make it integrated with the Radar 2 if you don't set it properly, because of the integrations is quite complicated for the Ghidra slate to be used by the Radar as after the parsers, and the Radar PM is having the good management for that. And then we will do the demonstrations. First is about the build test. The build test probably we will pick either a system-wide installation or user space. Probably I'm using system-wide mostly for the test, so probably I'm gonna just doing that in the FreeBSD environment, and we will do some basic tests after the build test was done. We'll test the interface like pipes, commands, visuals, and HUDs, and after that we'll do the static analysis either with the parser or the several architecture binaries, and debugging, invoking about how it is started with the -d or OODs, and lastly we'll do some testing of the ASIL, and let's see whether can be performed quite well. And also there is test build reporting that I would like to giving several examples for the reporting purpose. It will be shown in the screen after the testing stuff has been done. So let's get it done. So always refer to the Radar.org GitHub pages for the downloading of the new release version. So all you have to do is go to the which version that has been released latest versions, and scroll down to found the assets, and found the source code for the installation, for example in this one. So after you pick the source code, you can download it to your installation platforms. In this case, I'll do the FreeBSD thing for this one, and it is using the 12.2 version, which is actually currently are still listing, yeah, until the end of March next year. So it's quite good for doing the test. Then after the version is supported, and we can just start to download about the package of the source code that we saw before in the GitHub of the Radar, and all you have to do next is just extract the out of the box. There you go, it will be extracted just as per it is, and all you have to do is well, in my case, I'd like to make sure this is a release version, so I just rename this into kind of the BSD ways like this, and I just go to this directories and just first I have to make sure whether this version has the previous rudder or not. So it has the previous version, so all we have to do right now is try to get rid of it by uninstalling the previous version first. Okay, so the FreeBSD, you have to really make sure that to use the gmake instead of the clang make to do the installation and uninstallation script. So in this case, we will do the gmake for the uninstall or install or purging rather packages like this, and it's supposed to work like this. So after the previous version is successfully uninstalled, so you can try with installation of the new one. After you uninstall and purge the previous version, so you are very good to do the installation for the latest versions. So all you have to do is you go to the main directories of the where the makefile and the configure file are there, and over there all you have to do is just write the one command, and if the SUD are set well in your machines, and you will let the rather using that SUD for the installing the specific path for the library purpose. So all you have to do is just run this command like this. There we go. This is actually the summary about what being installed right now. It is showing the version of the 5.4.2. So here we go, the installation is starting. The compilation preparations is being start here. So I will pause the process so we can just skip it until the end of the this building process. There are several warning there that probably came up, so you don't have to worry about that as long as the error doesn't came up. Okay, it looks like the installation that has been done. So if you are seeing the messages like this, meaning that the installation that has been done successfully. So all you have to do depends on your flavor of the TTY. You can copy paste about what has been recorded in the screen, or you can also pipe what every SPT out of the message that the generated during the compilation process. So after you manage to get the installation log, this is actually contains the information that you will need to report if there is a bug is going on, or something's happened that is not as per plan. So in this example, this part, which is we can see the one with the final report, is a very important one, which is explaining you about what kind of the installations and what kind of the stuff that actually being installed and being detected running to your system right now. And if you are having a problem, please attach this report, or at least this final report is quite important for the developer teams to actually study about how the system is installed. And there is also another part which is explaining about the building environment and it is having another file report over here. It is explaining about what compiler that you are using, and so on and so on. Then the installation is running, and in this case the capstone is installed first, being compiled here, and then the components of the rudder will be installed afterwards. So this is actually the source code that being fetched and used for the compilations, which is having the main path of the library where the rudder source code is actually being placed. And these are the final compilation stages, which is generating the binary for the rudder use. And as you can see, most of the operations are using the gmake here, not using the make. The concept is using the ACR for the installations, and in the end the package is being installed and placed successfully. So since we are okay with the installation, so let's try it with some basic tests that to check whether this version is actually ready to use or not. So some basic operations can be used for this purpose. In example, well, first you want to be sure about the versions of the rudder stuff that you're using, and then let's see about the plugin components too. Well, we don't have a miss about that, and now we are having this. Then probably we would like to try to load some binary for the test. In BSD we have the test binary like this, and check about the whether the architecture and every detections are in the right place. This is correct, and we are having the FreeBSD running here with the AMDs, no problem. And after that we can start with some several basic analysis. For example, sometimes it crashes in the previous versions. We can see about the analyzing about the symbols, and let's check whether the symbols are actually being fetched properly. You can compare this result with another tools like ObjectDump or Redelf or any kind of the tools that can confirm but the reading of the imports or export here are correct or not. And we can increase about the analysis level, and let's see about the function list, stuff like that. This is quite important if we are going to use the analysis for the rudder. And let's start with these functions. It is printed quite well. For example, let's see with PDSF command, it can show the string quite well. So currently we are in here, I guess. No, not exactly. We are in here, so we may want to check some basic functions like PDC, for example. It has the PDCO that can help people to analyze some assemblies at some points. There are many ways that you want to check, for example, the dumping commands, and then the search, and search or seek or history, whether recorded or not, and check interactions to the cell. For example, let's check about the it runs very good, and let's see it here. And let's see, for example, you are analyzing some kind of a functions and like this, and probably after you analyze, so you want to PDF and you want to check the grep whether it's having the move commands, stuff like that. And there are many ways that you can do for the testing, like dumping with this result to another text files. For example, it's a ATXT, and you want to just write the ATXT here and showing the same stuff. So parsing is doing good so far for the basic testings. Now we can check for the visual mode, starting with V commands, and you can see this is the one that we usually see, and we can see whether the tabs are working well or not. It shows the changing between the ASIL and the non-ASIL mode. So we can check whether the visual mode are working well with some command that is only supporting in it. For example, I want to just make a flag in here with the name of the testing one, and it's working. So let's say commenting to anywhere that I want to do, like okay, this one, like this is a push. Okay, it is working, so that is no problem so far. If you are pressing the O, it should show about the exchange between the ASIL and non-ASIL. It is working for this visual mode. And we can see the menu of the D for the analyzing something. For example, you want to change several blob into strings. It's just a matter of the parsing and reading, so you don't have to be worried so much about something being ruined. For example, I want to set this as a string, then it should looks like this. Well, let's destroy this one too. Okay, so we are making it a very horrible assembly now, and the functions are working just fine. So this is kind of the testing for the visual mode, and there are many tools in the visual mode that can be done too. For example, if you want to search something or you want to highlight something. And setting for the ASILs, well, in this case I'd like to return to the entry 0. So just making sure that I'm in the right place. Okay, here we are. Good. So in order to do the ASIL, I have to understand about the current state of the ASIL. I will use this command just to make sure that I'm not gonna ruin anything. So just checking, make sure the cache is being set, and the setting for the ASIL can be seen here. It is set to the true and true because of we are playing with the ASIL actually during the visual mode for pressing the O button or tab. So it's actually being set for the emulations ASIL and strings too. Now we can check some several operations of the standard ASIL, like for example this command. This is actually the standard operators for the ASIL, so it's working pretty well. Probably we will try to start the ASIL for the virtual machine to start at the initiated and starting from this point, and then probably we would like to let's check like this. It's supposed to be moving. Oops. Habit dies hard. Okay. It is going to the it goes to 1, 2, and right now it's in here I think 3 times. So let's make sure that with the history command, so this is a 1, 2, and 3. So that was why I'm here right now, like from here 1, 2, and 3. Okay, good, great, it works. So let's check about the say I just want to go here. So in the ASIL it's supposed to be like this, and let's see. Okay, it works. Stepping is working, so I don't need this EAP anymore, and let's turn it off. Then probably the ASIL is working quite well, unless you want to make it further check, like just want to make sure about the IO cache, whether is it still on, true. So let's write about the so stuff like that is supposed to be written there. So let's see whether yep, the repe command is actually came up. So let's see about the what ASIL says about this. Okay, I don't think there is a problem at all with the ASIL until this point. I'm not so sure. Probably Conrad can do the more testing than me for the ASIL parts, but from my point of view, there is no problem with the ASIL engine in this version, this platform. So how about the debugging? Debugging can done instantly, like if you are turning this into OOD commands, and you can check directly to the memory after this, and let's see whether the reading is going as per expected. I think the assembly setting is a little bit weird, so let's make sure. Oops, it is a 64. Oh, it has the register of the 32 bits here. We are actually debugging in the 64 environment. This is actually the current existing program. So now this is not good. Stuck is crashed. Yeah, so it's supposed to run like that. So I don't think there is a problem with the debugging for this version, so can be considered as a unbuggy version. That was why it was set as a stable version. So it looks like it has no flow at all in the any confirmation that we were doing with these versions. So we done the interface static analysis test, debugging test, and the ASIL test, and we have a good reporting details with this, that it should be saved somewhere as a reference for us, for in case there is a new features being added and we want to compare. So this is it for demonstration of the building for this chapter, and there are several build examples that I'd like to show you. In this case is using the Debian stretch for the Raspbian of the ARM 64 devices, and you can see it here. These are the configuration. It was running well. Collecting stuff like this for the exotic CPU is quite one of the good preference for many kind of the setup in the IoT devices or the embedded environment. This one is for the ARM HF installations, so all of the information is there, the processes, and then the installations, what was detected and so on, and this actually being recorded for the development checks and errors that can be used for the reference for the future. So let's go to the next chapter. Oh yeah, before I forgot, there is things that I'd like to explain first. Well, this is the memo that I made around January this year when the version 5.0.0.0 was released as the first base for the new features. Okay, here is the top, and as you can see, this is a result of the very big test from the version 4 goes to the version 5, and in each major versions I commit to do the same stuff. So we try to make testing and focusing for the generic platforms, and these are the result that we gained at the time. So for the version 5 release with the git recent, we can support for the base binaries, and along with the functionalities of the standard decompilers and the new ASIL that has been developed by Conrad during the time. And it was also added with the backup repository for those platforms too, which is basically needed for the community that has been inaccessible at that era. So it has been safely we can support them and advise to use this backup repository for such plugins. And also there are plenty of bugs that are pretty hard that actually finally can be pinned down for the major versions, but these are gonna be discussed in the bug reporting session. So basically these are the space needed for each version of the OS. For there are Linux here, and OS X is in here, so we can compare what the size was actually needed for installing those version 5 with the necessary plugins. And separately, parallel with this progress, we successfully collecting several installations for the embedded devices. So I'm gonna list up here the part that has been successful installed since we raised the version into the version 5, which are these are several the images that we successfully obtained from the block devices, and this is actually the exotic CPU development sections that well, I personally maintain and build tests and implementations for the portability to be installed as a native tools to these embedded platforms. And all of these are having the Radar 2 installed inside, and these are the development tools, some tests, and then we are having Solaris here, and the other stuff are Linux that was listed over here. So I'm gonna show you one by one that it is actually work. Okay, it's successfully can be booted there. You have the PPCs running, and it will be good if we can do some simple debugging in there. Okay, the network is up, so it is having no problem for me to connect it. Then yeah, the Debian operating system is running in here. So there we go. Let's see. So let's check the environment that we are having now. So I'm gonna switch to the users mode now. This is the users mode, so probably we can just try to make a trial here for the for example this binary, and we just here is actually the binary itself after being loaded, so we can see all of the sections there. And here we are, quite interesting environment here. It has so few viewing. Need a better space for showing you the what assembly that can be seen here. Well, actually this 32 bits of the architecture PPC, and it runs. You can go to the N30. Let's change the format. It's not being scanned pretty much, but it already has the mark. We can go back there easily. If we see the debug command that can be performed here. So this is actually what the N30 and the libc start main link are looks like. So it will run as usual, but it has a very weird memory address that still need to be fixed. Or statically doesn't have any kind of a problem at all. For example, like this. So you can try with many kind of the stuff. So It is very useful to analyze something related with the BBC Linux. That is one of the stuff that we use. We successfully installed in the test field. So the spec of the hardware is not so big. We are having about this much of the memories, and the speed is not so fast also. It's based on the Power Mac G3 Silk, and it is installed with this Debian version. You can go to the another test devices. So this one is MIPS for the 64 bits, and having a little bit of the resources after some tweaking here and there. I'm starting the operating system now. So it is installed with a stretch. Let's switch to the client version, or probably you want to see the spec first here. Well, the simple thing to do is grab this environment with this looks much better. Well, this is we have a 200 megahertz speed. It is actually having architecture of the MIPS in 64 bits, and currently we are having this memory. If you see the top, you'll see it much more. It's quite fast and not taking so much load here, and it is having rather installed too. It took a while. Here we are. It took like 2 or 3 days to set up this device. If you are asking it to directly to the Debian, it will set that it is MIPS 64. This is actually the package that's being installed. So, for example, you want to check with the same binary here, and this is actually the binary that with the code is different. It's in a MIPS platform, and you want to check about the MIPS, so it doesn't make differences or problem. Let's try to put it into the memory. So it's working, and now we can show the registers. Okay, it looks like this for the MIPS environment. The same binary that we are having before, and if you want to do the stepping, it goes like this. You can't see it well, probably here. Okay, it is running and can be used for the debugging. This is a matter of the locale problem. So, for example, I want to just and let's see. Okay, it's fixed. So it doesn't making much difference. We are actually here right now in the loader, so start it now. There you are. Raspbian is learning. Well, not so much differences between the Raspbian and the Debian itself. It's it's based on the Debian for the mobile environment, and it runs pretty well. Well, for this demonstration purpose, I'm using the root account, but I'm not using those for the daily basis. So here we go. Forgot the password for this one. Probably this is the correct one. Yeah. Okay, here it is. So it's a Raspbian. So if you are asking, it's an ARM 6. Raspberry Pi. Making this image is taking a very long time. You have to get the everything outside, and then you build it from there, and this is one of the result. Then for the rod array, let's see. Let's load the same binary so we can compare the speed. Okay, so let's try this. It took a while. With the Raspbian, it's quite slow. Go something like this. Well, actually, same bug appears, so I have to clear up the local first. Stuff like this will help. Well, here it is. It's a very cute, very small, so it runs. And for the any kind of a practical purpose, it is can be tested running in the memory like this. Go to the visual mode and run the HUD. So there you go. Let's switch between HUD, see whether this can be used. It is switching. There you go. The menu is coming up. It took a while, but it works. Then let's wait for a while till it exists. So stacks look like this. If you go to the debugging, so you'll see an alive stacks over there running. And this is actually the some of the Majestic devices that actually successfully installed. There are more, as per seen in the list. We have many, and I'm still working to install some new stuff too to add these collections. So we are ready now to go to the next chapter. Well, we go to the next chapter, and this chapter is about the bug hunting and contains about the playbook, how to handle the bugs in the Rudder 2. So let's be prepared well and stay tuned. Playbook to handle a bug in the Radar project is understanding first about what package to test. Is it Radar 2 core binaries like Radar 2 or Rahas 2 or Rabin 2, etc. Or commonly used plugins. There are two types of plugins that I've already explained before. What I mean here is a plugin that is being managed with R2PM, and then you have to know what functionality to test that is most commonly used by the users. It can be a binary analysis, and binary analysis can be performed through the radar binaries, or can be also being confirmed or tested through the each binaries like Rabin, Rex, Rag, and Rehas, etc. And then the other functionality is forensics. Is not as much as a binary analysis, but it's there. So it has several commands and some loading tests for try to load the image, for example. And there is also an approach to a quality control testing approach for the core, like for example the build fail, the basic functionality interface like parser failure, CMD failure, visual or HUD bugs, and there are not so much, but few of them sometimes came up. Basic functions of the ACOs, and we have a lot of bug related to the debugging, and one more is related to the forensics activities of the curving. And the last one is related to the vulnerabilities, can be confirmed with regressions searching. In this case, standard regression in usage. It is limited to the known bugs that's being used for the QC testing approach. Then we are having the plugin testing, which is we have to know every plugin matched to the specific R2 versions, and which version is that, and what plugin are actually maintained by whom. Either is gonna be in the Radar mainstream or not. You have to be careful with that. And they are commonly used plugins like R2 Ghidra, for example, R2 Frida, etc. That is making a higher priority for testing. And also there are limitations, like we cannot test them all. All of the plugins is too many of them, and all of the user interface is kind of the command or any kind of the parsing methods. And there are a few distribution support plugins and interface right now, so we have to really be careful with resources. And you can trace the build commit openly, but not as open for the plugins. That is the way I tried to learn it so far. So the current bug fix scheme in Radar GitHub, the way I see it so far, since I joined the GitHub community of the Radar around 2012, 2013. Previously I was using Radar under the FreeBSD ports and directly from the what Pancake released in the first version. Right now in the GitHub, it's more like, the way I see it, is more like what the Red Hat does or did in the version 6. It looks like something like this. So the explanation is a report of the bug is coming, and gathering more informations in here, and if can be decided as a new bug or new report, it will be generated as new issues, and then when starting to assign, it will start to post about the issues here, and then we have to study about the reporter information too, and several check was performed after the assignment is done, and sometimes many of the details of the bug will be modified to be more precise and more curable, and that is actually depends on the which branch of the development doing that. And development will be started. After development is started, so it will going to this loop again. Is it gonna be modified or not modified? And after that goes to the quality control. That mostly Pancake is handling this stuff and verifying, and then the bug then will be closed. But that can be reopened again to be assigned to another person's, or by that person's can be modified and going on the development once more to be then on the QA verified, close, and then to be merged into a fix. Well, this is actually the current bug scheme of bug fix scheme in the Radar in the GitHub. And you have to know also about how to troubleshoot the bugs. I always refer to what Pancake is working with, and everything is actually described in these slides. It has the three things that you have to really know from there, which are directory structures of the Radar projects and code structure, and lastly the base building process. So it is in the R2CON 2021 in the day one, I think. Pancake was doing a great presentation about this. So you have to take a look into the slides. It has a very important and recent information over there. So understanding those three concepts, you can really know exactly what from which part of these development sections that the bug is actually coming from. First is about the directory structures. Practically, it has the explanation in this slide explaining about the directory of the which one is libraries and the main binaries, and then the external libraries, for example, Capstone and so on. It is in these directories, and more explanation can be seen in the slide from Pancake. And it has the code related structure, like defining the public APIs are prefixed with something, and then the public function name should be start with some kind of the namings with R underscore something, and so on. You can see it in the code structure slide or in here later on. And the most important part is there are external projects synced with R2 for the source compatibility reasons. So you have to be careful to pick one, to seek one, which one is actually the source of the bug. And there are also capstones and vector 35 for the binary parsing. It may be one of them becoming the source of the bug too. So it's a really difficult decision to decide which one to be fixed and which one is really responsible for the fixing. And then lastly is a building process. This is the things that we in the testing should know it better than other people actually in the community, because of mostly we are dealing with a build error and have to check it to be build error free. We have to make sure that every users are downloading the package from this repository and has to install it with this way, or else another installations will be considered as a custom, so we will need more communications and more regenerations to fix it. It will be lowering the support level. And it has the ACR, which is commonly being used right now, and even though there are also CMake, and depends on the system. The GCC is actually, for example, in the BSD becoming CLang, and if you are using the OS X, the CC is also CLang, but in the Linux probably mostly ACR will work. So this kind of the stuff that has to be understood, and we are having some plugins that is compiled through the CMake, I think, and we don't like to use the CMake because it's making too many compiler exist in the one system is not so good. So practically we will, according to the Pancake, we will focus to the ACR and native compilations more than the installing some other extra compilers. And the standard is important for the C syntax. Right now is a C90 is a support, is a base for the coding. These are the concept that the tester that should understand. And there are some more reference cannot be mentioned all of them in here. For example, this is rather a book. It is downloadable from the internet. Please download them so you can study or try. And there are several concepts that is actually written in there. And there is also resource link. For example, this from R2CON-2021 that I compiled, and also there are others resources like awesome or rather true materials. I think the previous developer was doing this in the first place. So this is actually the resources that can be used for understanding more about the internals of the Radare for handling the bugs. And after you do the bug hunting, you will need to know about what kind of the bug that actually exists and how to handle them. And along with that, the reporting is also a must. So the documentation is everything. So we are engineers, so we have to keep everything recorded for the sake of the improvement. So bug reporting also has to be done in the same situations. In the bug report, it is important to know about the background story of that bug. For example, is someone is analyzing something which is unusual, and then the bug can occur, which is probably has not been predicted before, or there are some other circumstances that making the bug is unavoidable, and it's not supposed to happen, but actually can be avoided with another way too. So all of the information is important not only for the fixing, but also will help us to advise the workaround when the developer teams is trying hard to fix those kind of bugs. And the next is environment informations. So you cannot just say that hey, my system is a FreeBSD, this Radare cannot be compiled. What to do? Now you have to know that in the FreeBSD itself, it has so many things that can be used in the port to install something. So you have to be more specific than that to explain about from where that you download Radare for the installations. For example, in every distribution, probably it has a packages that is support the installation of the Radar 2 for the specific distributions, and in the FreeBSD it has it also in the port. But for that, you'll have to ask for the port maintenance first. But if you are downloading it from the GitHub, so probably the best way to do is to directly to write issue in the Radar GitHub. That is the important of the environment information. The next is the bug visualizations. So this is a very high requirement here to make all of the people in the community to understand about this bug, like a screenshot or a video, or probably a smart playback SSL interface that can explain how the bug occurred in the first place. And then along with, you have to always provide how did you install Radar, and how to get the installations log, and that data is very important. Most of the data to fix is in there, so like 70% of it, and then the other stuff is based on the explanation that you're given here or here. Then please attach them if you can, and that will be very helpful. So when you install the Radar, be prepared to get the log just in case some problem occurred. And you have to make a description about the which part of the Radar components is actually affected to the bug, because Radar is a very complex framework. It has so many binaries inside. It has the core binaries, it has the supported binaries, it has the third-party binaries, it has the plugin binaries, it has so many binaries. So you have to be precise about that. Otherwise, we will have to troubleshoot one by one, which is taking a little bit more time. And especially developers are so busy to code and to build something, and we have to actually provide vectors about the how to fix this bug, so everyone's time can be used for the most of the optimizations. And the bug regeneration information is important. Either gonna be a commands that can trigger the bugs, or set up ways that can trigger that bug. The setup ways can be related to the environment information. For example, in the shell, it has the shell macros or variables or other environment data that probably will affect the way you install that Radar 2 versions. And then the usage, the way you use the Radar for some activities that probably can cause that bug too. And from now on, these are the optionals. The first is the problem source. Probably you can see the problem of the bug itself is coming from this source code, for example. So it will be a very great hint for all of us in the community. And if you know how to bug fix that bug, please advise us to do so, or well, it will be very grateful if you can help to code that too, and that way Pancake will be very happy, and your name will be mentioned in the GitHub of the Radar 2. And lastly, if the bug was caused by a sample or a script or etc., that data that can cause that bug to happen, please try to share those. If you cannot share it openly, you can try to ping any of the Radar community people to help you to pass those data privately, so the regenerations can be performed under the non-disclosure agreement or understanding, so the bug can be fixed. This is the example of the environment informations that being sent to nail a bug. In this case, is we have the date of the when the bug was reported or spotted, and then the which version of the radar that actually causing the bug, and then we have also the which kind of the operating systems that actually being used for when the bug is actually being spotted. And you will see the in the bottom architecture or the platforms or the OS and CPUs informations that being used during the bug happen. This information is very important, and if it is recorded properly, can be used as a history to be traced if bug sometimes after being fixed will be reopened again, and we have to seek into which date, and if the date is there is very helpful. And the visualization like this screenshot or a video and can be seen in the another slides. It will be a very good information for the developer to fix it. And the clear bug description is the best way to make it being pinned easily. Like in here we have bug details about this in this case is about the FreeBSD. I think the make uninstall and make purge didn't work before because of the actually the environment of the FreeBSD is different with the Linux in the usage of the compilers because of the these FreeBSD is dropping GNU and starting to use the LLVM, right? Call it developed based on the LLVM called Silang. So it has some differences, and in order to make rather can be compiled, the solution is can be guessed in here. So the problem is being defined here, and this is the actually the versions that where the bug is being spotted. Summary is written here, and the affected OS is written over there too. Then using this clear description, probably you know about the solutions, so you can put some kind of the option of the solution for the community or developer or Pancake to decide which one is the best to fix this bug. Because of what you think about the FreeBSD is good, probably is not very good for rather a installation for another operating systems too. So that decision has to be made by the maintainer, and we have to just give as much option as possible. And for the POCs, log and the screenshot is gonna be like this. Is mostly what I already explained about the installations. Like we have the here the mix install and mix uninstall doesn't work, so you have to provide the output data of the that command, for example, and to see in which kind of the error number or error informations that actually the bug is happening. And that is a quite important hint for the fixing in the developer perspective. So, and the best way is probably you can provide some workaround. The workaround can be used as a good advice, not only for the developer but the other friends in the community, which is probably also affected to the bug but don't know what to do. So if you have workaround, please advise it together with along with the bug itself, so it will help the others too, and that will make the community of the Radar becoming strong and not get easily to be stuck because of one trouble or one problem or one bug that can affect everyone. And For the several examples of the previously explained points, I've already provided some data. This is the one that I told you before about the make uninstall and make purge for the FreeBSD doesn't work. So the solution is to make a gmake uninstall or gmake purge, meaning that you have to install the GNU package of compiler in the FreeBSD, and probably not so many people in the FreeBSD agree with that. But actually, what is needed is only the gmake, because of the compiler itself is using the clang, and that goes pretty smooth in the OS X, which is actually the base is very the same with the BSD basis. So you don't have to use the all of you don't have to change all of the your compiler actually, but the make packages has to use the GNU packages one. This is the package that's actually being needed, so you don't have to install the other packages of the GNU compilations. And after being fixed, you can explain, oh, this is gonna be fixed like this. This is the screenshot. When the bug was occurred, you have to provide some kind of summary like this, explaining when it happened, in what kind of distributions or operating systems, explaining about what happened in the most easy to understand ways, and provide also the solution if possible, and make some kind of options, and you provide the log of the build, stuff like this, that so the developer can see that oh, it has this kind of the errors happening, something is not right in that part, so community can try to fix it more sharply and faster. Another bug probably still reside until today. This is the bug related to the plugin. So if you run, this is a very hard to understand bug. So in that case, this reporter is providing the video for it. The video is in the YouTube. If you click it, the video will appear, stuff like this. And in the video will explain about how actually the bug will happen and when it happened. For example, in this part, in this case, PDC was run, and then this is the bug. So you cannot see any of the output as becoming garbled. And for you who doesn't probably understand but how the GitHub is actually working, if you see and starting to use the RAD array, and then you find an issue that you are strongly thinking this is a bug, so you just click this issue, and you can select this button for the new issues, and then you can it has three options here, so you can pick the bug report, and over here it has this questions that you have to fill, like the date, the versions, the uname of the your operating systems, and then explain the issues over here, and then the step to produce the bug itself. And with this base informations, you can write the short title about what this bug is all about, and then submit the issues, and communities, especially the developer, will check and try to figure what is going on. And when the issues is happen, so you can see it here, it has so many issues is actually being posted, and it has very good description, for example, environment description, how to test it, and so on. And developer will comes to you and will have communications about how to fix that bugs. For example, in this one, it is providing about the informations about how the bug is occurred, and is having the sample about how handling that, and the communication is being made directly with a pancake in this case, and the fixing is started in the process. So this is actually how the bug can be pinned in the Radar. Even though the bug fix scheme is quite simple like this, if you are working together, and we are thinking the best for the communities to keep on going as the open source, and I ask for your corporations for providing us your help in the testing or in the making escalation of the bugs that you are seeing in the daily basis. So by saying that, herewith I conclude my presentations, and thank you very much for watching. And if you have any questions, please try to ping me during the conference here now, or if you don't have time to do the live with me, and you can always reach me with questions or requests through this Twitter account, and you can DM me for that. And please mention that it is about the R2CON 2021, and I will try the best to assist you. Thank you very much.